You know that world map we all have in our heads? The one with the 7 continents? Well, it feels pretty permanent, doesn't it? But really, it's just a temporary snapshot in an absolutely immense cosmic dance. Today, we're going to hit fast forward, way forward, about 250 million years, to explore the incredible scientific visions for Earth's next supercontinent.
So, what will our planet actually look like in that deep future? It's a huge question, and right now, geoscientists are using supercomputers and these amazing 4D models to try and figure it out. And let me tell you, the answers they're coming up with are nothing short of spectacular. So let's dive in and see what they found. All right, here's the game plan. First, we're going to talk about the planet's fundamental rhythm, this grand reshuffling it does. Then we'll get into the really cool part, the 4 competing scientific scenarios for the future. After that, we'll unpack what it all means for climate and life, then check out the impact on our oceans and resources. And finally, we'll take a step back and think about our planet's ever-changing nature. So our story really begins with a process that's been shaping our world for billions of years. It's called the Supercontinent Cycle. And this isn't some one-off event. You got to think of it more like a grand, repeating reshuffle of every single piece of land on Earth. So what exactly is this Supercontinent Cycle? Well, in a nutshell, it's kind of like Earth's pulse. Over hundreds of millions of years, the continents we know and love drift together to form one giant landmass. And then, poof, they break apart and scatter all over the globe again. It's a cycle that just keeps repeating. And trust me, this has happened a bunch of times before. We're talking way back, from Balbara over 3 billion years ago, to Kennerland, then the more famous Rodinia, and of course, the one we all learned about in school, Pangea. It was Pangea's breakup that formed the world we see today. This timeline just shows you what a long-established pattern we're dealing with here. But what's driving this whole thing? Well, it all comes down to heat, specifically the heat from Earth's core. A supercontinent is like a giant thermal blanket. It traps so much heat from the mantle underneath it that eventually something's got to give. The mantle pushes back, and it literally rips the continent to shreds, sending the pieces flying once more. Okay, so the breakup of Pangea is what set our current continents in motion. And that means we're about halfway through the current cycle, which is pretty cool because it means scientists can use these incredibly powerful models to project forward and see how the continents might come back together. And that has led to 4 main scientific scenarios for our planet's future. This chart does a great job of summing up the 4 competing models. It really all boils down to 2 key questions: which ocean closes and where does the new supercontinent end up? The assembly mode you see there is just the fancy term for how it happens. Like, do the continents just keep going and meet on the other side of the world, or do they hit reverse and close the ocean that just opened up? So let's do a quick rundown. First, you've got Novopangaea. That's kind of the business-as-usual model, where the Pacific Ocean just keeps on shrinking. Then there's Pangea Ultima, which is the exact opposite. It's an introversion, where the Atlantic closes back up, smashing the Americas back into Europe and Africa. Aurica is a bit more complex. Both the Atlantic and the Pacific close, creating this new landmass right on the equator. And finally, Amasia, where all the continents decide to drift north and have a big party at the top of the world. Now here's the really crucial point. This isn't just some abstract geological thought experiment. The shape and the location of a supercontinent will have profound, and in some cases absolutely catastrophic, consequences for the climate and for life itself. One recent study, which focused specifically on that Pangea Ultima scenario, paints a particularly grim picture. It warns of what it calls a triple whammy of environmental problems that could kick off a mass extinction event that rivals the worst our planet has ever seen. So whammy number 1, the insane amount of volcanic activity from all those continents crashing together would pump just enormous amounts of carbon dioxide into the atmosphere. We are talking levels that could soar past 1,120 parts per million. For context, that's more than double where we are today. Whammy number 2, you combine that CO2 with a sun that's going to be about 2.5% brighter by then, and you get a runaway greenhouse effect. Maximum temperatures in the vast, dry interior of Pangea Ultima could hit a staggering 70 degrees Celsius. That's 158 degrees Fahrenheit. Just unthinkable. And the result, the triple whammy? Well, the vast majority of the land would become completely uninhabitable for mammals, and that includes us. Some estimates suggest that as little as 8% of the entire supercontinent would still be livable, mostly just in these tiny little fringes near the poles. And this chart just illustrates the difference perfectly. I mean, look at that dramatic drop for Pangea Ultima, from 66% habitable today down to 8%. It's shocking. Amasia, on the other hand, forming up at the pole, would be an icehouse world, but still mostly habitable. And then there's Aurica, right on the equator, a temperate world where basically all of its land could support life. It just goes to show you, location is everything.
But the changes go way beyond just climate. When you assemble a supercontinent, you fundamentally reshape the world's oceans, its tides, and even where you'd find its mineral wealth. Let's dig into those hidden consequences.
So, fun fact, did you know our tides haven't always been this strong? It turns out we're in a period of really high tidal energy right now, all because the Atlantic Ocean happens to be just the right width to resonate with the tide. As the continents shift around, that's going to change. And in a fully formed supercontinent, the tides would become incredibly weak. And get this, some of these models predict some truly bizarre new bodies of water. The Pangea Ultima scenario, for example, creates this central landlocked sea. Because it's cut off from global circulation, it would become stagnant, super salty, and basically super toxic, maybe even releasing poisonous gases into the air. Yikes.
Okay, but on a more positive note, this entire cycle is also the engine that creates and concentrates the mineral resources we all depend on. The collisions, the quiet stable periods, the eventual breakup, each stage forms different kinds of valuable deposits. We're talking about the copper in our wiring, the gold in our electronics, the uranium for nuclear power. This cycle literally creates the planet's treasure chest.
So, let's pull all these different threads together. What does this all tell us about the long-term future of our planet, and maybe even our place in it?
Well, while nobody knows for sure which of the four scenarios is going to be the winner, the scientific evidence is definitely starting to lean in one direction. See, as the Earth continues to cool down, it gets easier for the older, colder floor of the Pacific Ocean to sink, and that favors models like Amasia or Novopangaea, where the Pacific closes up for good.
And luck. While the formation of the next supercontinent could create a world that's just too hostile for mammals to survive, it is so important to remember that this is a cycle. The end of one era is always the beginning of another. The eventual breakup of that future landmass will create new oceans, new shallow seas, new coastlines, providing the perfect cradle for the next chapter of life on Earth.
It's just a profound reminder that the world we know isn't permanent at all. It's just a single, fleeting frame in a planetary story that is constantly unfolding around us. The face of our planet is always changing, and while we've explored the possibilities, the final question is still out there. What will it change into next?